We're going to now finish with a couple of sections that deal with probability. This will be useful perhaps if you go on to take Math 11 or another statistics class. There will be a whole chapter on probability. We're going to start off here with what's called the fundamental counting rule. Basically, if you have a sequence of two events labeled A and B, in which event A can occur n different ways and event B can occur m different ways, then the events together can occur n times m ways. This would sort of be like saying, if you had 5 different shirts and 3 different pair of pants, how many outfits could you have? Well, that would be 5 times 3, or 15 different outfits, different combinations of your shirts and pants. So, how many ways can the letters A, B, C be arranged? Well, they could be ABC, ACB, BAC, BCA, CBA, and CAB. 6 different ways. How many ways can the letters A, B, C, and D be arranged? Well, if we let A be the first one each time, the other 3 can, of course, be arranged 6 ways. And then, of course, we could make B be the first one, and then there would be 6 ways to arrange the other 3 letters, or C, or D. And so, since you have 4 letters, 4 different ways that you could start it out and end up with 6 combinations, there are 24 different ways to arrange the letters A, B, C, and D. Now, a quicker way to do that is to use factorial notation. We talked about that in an earlier section. Again, just to remind, if you look at your calculator, if we use the PRB button, we have the third one over, which will be the factorial right there. So a little bit hard to see. That's a little bit easier there. You can see the factorial there. And so if we wanted 4 factorial, so let's clear that 4, hit the PRB, slide it over to the exclamation mark. So 4 factorial equals, and there is our 24. A much easier way of doing so. And as mentioned before, the factorial symbol denotes the product. In other words, all you're doing is multiplication of a decreasing set of positive integers. And so 3 factorial is 3 times 2 times 1, which is 6. We've already shown the 4 factorial, and so forth. And then notice how the total of 3 factorial, the 6, matched the 6 ways we could arrange 3 letters, and that the 4 factorial matched the way we could arrange 4 letters. One way to kind of think about doing the factorial is when you have 3 letters to choose from, any of the 3 could be in the first position. And so there's your 3. But once you've placed one of them first, there are only 2 of them left to be in the second position. And so there's your 2. And then once you've placed both the first and second one, well, then there's only 1 left to be in the third position. And so you have your 3 choices times 2 choices times 1 choice, or 3 times 2 times 1, which is 3 factorial. All right, so we have looked before at NCR, which there's a couple of different ways you can show NCR. You can show it this way, NCR. You can also show it in this form, N over R means the same thing, or sometimes a book will show it as C with the N and R in parentheses, and we already showed that that was N factorial, R factorial, and N minus R factorial. What we didn't really talk about is what the C represents, and basically that's the combination rule. How many ways can you combine your choices? However, the combination rule does not care about the order. And so where up here we said we had 6 different ways that we could write the 3 letters, in reality each one of those had the letters A, B, C, and so there was only one combination, A, B, C, regardless of the order. That's the combination rule. There is also what's called the permutation rule. The permutation rule, which can be PNR or NPR, is n factorial over n minus r factorial. Notice that basically it's very similar to our combination rule. It just has the one part missing. And in this case, the order does matter. And so using NPR, we would have gotten 6 for this, whereas if we were using NCR, we actually would have only gotten 1. Now, order matters. ABC, of course, would not be the same as CAB because it's a different order of letters. Now, to mention, back to the calculator for a second, when we use our PRB, so you can see there is the NPR button, and then you slide it over R for the NCR button, and then the factorial is the last one. And again, these are all with the PRB, which is for probability. All right, so the big thing for this particular section is, first off, are we trying to figure out how many ways we can arrange a series of events? Then we're going to use the counting rule. Or are we talking about only doing a selection of all our possibilities? Because remember that before, when we were using the NCR, the N was the total number, and then the R was how many of the total number we were trying to pick. So in other words, it was like, which term are we interested in? The NPR does the same kind of thing. It's just that the order matters in this case. But in both of these, we tend to use these for when we don't want to take, for instance, everything. It would be more like saying, okay, you know, I have 4 letters. How many ways can I pick 3 of the 4 letters? That's what NPR and NCR are looked for. So it's a selection. So fundamental counting rule when we want them all, and then we tend to use NPR and NCR when we only want part of it. And we'll see some examples in just a minute for doing so. So using our calculator, let's see what these particular things are. So first of all, P93, which is the same thing as writing 9P3. And if I use my calculator, so I'm going to clear it. I'm going to go 9 and then hit the PRB. I'm doing the first one, so equals, then the 3, and then go ahead and hit equals, and it comes out to 504. All right, now let's do 16C3. So let's go ahead and clear it. We'll do our 16 PRB button, slide it over to the second one. Oops, too far. Equals, then the 3, and we get 560 on that one. Okay, 100 P5. So 100, and then that equals, and the 5, and we have this huge number. So you can see that P grows pretty far. So basically here we got 9, and then 034, and then 502, and then 400. And now we're going to look at 100 C5. And so 100 PRB, move over 1, 5 equals, and a big number, but not as big as what we just had. So that one there. And then this one here, this is the same as writing 8C0. And you might remember from before that anytime we end in 0, it's just a 1. So let's go ahead and do that. 8 PRB, move over 1. Then our 0 equals, there's our 1. So mostly I just had this one in there so that you could see the different ways of asking the question, and then a little practice using your calculator to get the right results. Alright, so how many ways can you arrange 10 songs on a playlist? Well, we're talking about all 10 songs, so that would be 10 factorial, which, again, using our calculator, 10 PRB, go over to the exclamation, so there's our 10 factorial equals in 362,8800, so 3 million ways. Actually 3.6 million ways that you can arrange 10 songs. 20 factorial. So if I do 20 factorial, let's see, again, 20 PRB, slide it over, equals, and then equals again. And this one does not give me an exact number, because the calculator can only display so many digits, but writing out all the ones I have, a very big number, and obviously it doesn't take much to get up to the point in which it will exceed what your calculator can do. Alright, so and again, for both of these, we had 10 songs to choose from. How many ways can we arrange all 10 songs? And here was how many ways that we can arrange all 20 songs. So these would have been using basically the fundamental counting rule. Alright, now in number 3 here, we're going to look at not all of it, but just a few. For example, let's suppose that we have 18 throwers in a meet. How many ways can you finish 1 through 6? In other words, we're only going to select 6 places of the 18 throwers. We're not going to worry about the ones who finish 7th or lower. So all 6 get a medal for finishing in the top 6. How many ways can the medals be handed out? If what we're talking about first is that the medals are different, in other words, 1st, 2nd, 3rd, 4th, 5th, and 6th, they'll be printed on the medal, then order will matter. It's different if you're 1st or if you're 2nd or so forth. In the second question, we're looking at if all 6 get the same medal, so it's more like, you know, you got a medal, more participation, but you had to finish in the top 6 to get it, so how many ways can the medals be handed out? So the key is this one over here, the order matters, and this one over here, because it's the same medal each time, order doesn't matter. So for this one, we would use 18, because that's how many throwers we had total, P6. Over here, because order doesn't matter, it would be 18C6. And that's really the thing you have to figure out before you do any calculation. Am I using the permutation rule because the order matters, or am I using the combination rule because the order doesn't matter? So for the 18P6, turns out that there are 13,366,080 ways. And then over here, 18C6, there are only 18,564 ways. Because of course, those who finish in the top 6, it doesn't matter whether you were first or sixth, and so it really cuts down the number of possibilities. All right, now it is possible to extend this to an additional situation such as this. A crate of 25 apples has 5 bad apples. How many samples of 3 apples can be drawn in which all 3 are rotten? Well, in that particular case, there are only 5 bad ones. You don't care in terms of the order, and you want to know how many ways can you pick 3 of them that are bad. And so this would be just 10. Okay? And again, there's only, even though you have a crate of 25, there's only 5 bad ones. So you want to know, in picking 3 of them out of the 5 bad ones, how many ways can you do that? And so really what we're looking at here is, the first one could be the bad one, and the second one could be the bad one, and then you have 2 good ones, and then the 5th one's bad, or you could have the first 3 are bad, and then the last 2 are good. That's really what it's asking, how many combinations can you have 3 bad ones? But there's only 5 total bad ones. Now, because even though there are 20 good ones, we're not distinguishing between any of the good ones. Now the next question is, how many samples of 3 apples can be drawn in which there are 2 good apples and 1 bad apple? Okay, well, first off, for the 2 good ones, there are 20 good ones altogether, and we want to draw 2 of them. Then, for that 3rd apple, which could be picked first or second or third, there are 5 bad apples, and we only want to pick 1. So we have 2 situations. Of my 3 apples, 2 will be good, 1 will be bad. Well, the 20C2, because we have 20 different good apples to pick from, 20C2, we want to pick 2 of them. There's 190 ways to do that. 5C1, this was another rule that we talked about before. Anytime you have a 1 as the R, then the other number is actually what the NCR equals. So in this case 5, and so 190 times 5, and there are 950 ways to pick 2 good apples and 1 bad apple from my crate of 25 apples. Now, you might say, well, wait a minute, there's just 2 and 1, that's 3. No, you have to consider those 2 could be any of the 20 good apples, and that 1 bad apple is any of the 5 bad apples. And so that's why there's so many ways that you could pick that. And then in our final example here, we have a bag of marbles. It contains 3 yellow marbles, 4 white marbles, and 8 blue marbles. How many samples of 2 can be drawn in which both marbles are blue? And again, they're both blue. You can't tell one blue from the other blue, so the order doesn't matter. But we only have 8 total. We want to pick 2 of them. So there are 28 ways to pick 2 blue marbles. Now, again, this whole section is about finding how many ways something can be done. In the next section, we'll talk about probability, and the key to what's called a frequency style of probability is you want to know how often something can happen, and then that gets divided by all the possible ways something can happen. In other words, what we found here in this last entry would have been how many ways to have 2 blue marbles, but if we wanted what was a probability of picking 2 blue marbles, that would be this divided by all the different combinations that we could have picked from our 15, 3, 4, and 8 marbles. And so that's what we're going to in the next section.